API 1104, welding of pipelines and related facilities. Here you can see welding of pipelines and related facilities standards, API 1104. And if you go to the table of contents and see what it includes. So after scope, normative references, terms definition, spec, it talks about qualification of building procedure, procedure qualification, qualification of welders, welder performance qualification, and design and preparation of joint and welding, and post-weld preheat, inspection of testing of production valves, certification of NDE personnel, acceptance standard for NDT, so acceptance criteria also is included, repair, removal of weld defects, procedures for NDT, and the other building like essential variable, non-essential variable, qualification, automated welding, and accepted standard for NDT, etc. And there's lots of figures here that you can see, and tables, list of tables here. So in this module, you shall learn about API 1104, building of pipelines and related facilities, Section 3, terms, definition, acronyms, and abbreviation, Section 4, specification, 5, qualification of welding procedures with filler metal additions, qualification of welders, design and preparation of a joint for production welding, inspection and testing of production welds. So this would be, we need to focus on acceptance standard for NDT, repair and removal of weld defects, product procedures for non-destructive testing, NDT. So it not only gives you the procedure, but also the acceptance for NDT, the welding. So it's a complete standard, and it's a single most important standard for welding of pipelines and doing the NDT, the acceptance criteria, the procedure, the welder qualification, and everything. We go through some terms definition, indication, imperfection, or discontinuity, and defect. Indication means a response from ND examination that may be valid or invalid. For example, two metal press fit would show a line indicating during MT or PT examination that is not a discontinuity because it's inherent in the design. So when it's inherent in the design and manufacturing of the parts, then it's not relevant because it's already there, it's inherent. It's therefore an intended or planned indication and hence not considered as a discontinuity. It's also called invalid or irrelevant indication. If a response or indication observed during ND examination is valid, then it's called the discontinuity. It means that such discontinuity is not inherent or intended, it is not intentionally created, but is the result of manufacturing, mechanical, or metallurgical discontinuity. If the size and type of such discontinuity is within the acceptance criteria that can be found in the construction code, then it is accepted and left as is, and sometimes called the recordable discontinuity. Here the construction code is API 1104. On the other hand, if such discontinuity is beyond the acceptable size, then it's called the defect and need to be removed and repaired. It's sometimes called reportable discontinuity. In conclusion, a defect is a discontinuity, albeit an unacceptable one, but not every discontinuity is a defect unless beyond the acceptable criteria. Similarly, discontinuity is an indication, but not all indications are discontinuity unless shown to be valid and relevant. You can see here the position of welding is always 5G. Let me say half hour, but 5G is here, and there is an internal concavity here, and you can see here the brighter light because the less material here on the concavity is concave, It's not fully filled in, and so more rays pass through the radiograph, so you have a brighter side here than the rest of the belt. This is the bed of the belt. The 5G position is the pipe do not rotate, but electrode rotates and deposits the weld. So almost all the pipelines are 5G because it's easier to move the machine around the pipe than these big pipelines to move around, and especially when they are welded together, several of them. 1G position is when the pipe rotates and the machine remains stationary and the weld is getting deposited. So this is highly unlikely for production weld or pipeline. Most of the time it's 5G. Repair any grinding or welding on a completed weld to correct the defect after NDE examination, and rework is the same activity as a repair. For example, grinding to remove an imperfection of welding, but before the NDE examination. So when we say rework, it's normally before a defect is detected by the inspector. So it's the same work, but it's just before it is detected. So the welder himself knows the weld it needs to be repaired, so he would repair it and then present it to the inspector. The same thing happens when the inspector detects it and the welder repairs it. So rework is not considered repair because the remedial or corrective action was done prior to the rejection of the weld. So the weld was not rejected, so we call it a rework. So always encourage welders to do the rework, so before get stopped and asked for a repair and the weld gets rejected. The manual welding, semi-automatic welding, and automatic welding. In manual welding, all parameters, amperage, voltage, speed, angle of electrode with respect to joint are controlled manually. Semi-automatic welding, the most popular and widely used. Most parameters are set automatically, while only the filler metal feed is controlled manually. In automatic welding, all parameters are set automatically during welding. So the most popular one is semi-automatic, where the filler metal is fed by the welding operator. Specification: equipment should be maintained and operated within the amperage, the welding equipment, and voltage range, and calibrated. Piping material are such as API, 5L, ASME material, ASTM material section, and MSS and ANSI. Consumables: all filler metals and fluxes shall conform to AWS classification such as AWS A5.1. So filler material as per AWS classification. And A here stands for ferrous metal. It might be a potential question. Coated filler metals should be protected from moisture that causes hydrogen-induced cracking. So moisture in the electrode might induce hydrogen-induced cracking, or HIC. Low hydrogen electrodes should be baked in oven or shrink wrap prior to use. Any filler metal and flux with signs of damage and deterioration shall be discarded. Shielding gas are either inert, active, or a combination. Argon, helium, CO2 dioxide, carbon dioxide, CO2, or mixture. Shielding gases shall have a composition certificate and the gas capsule secured, changed, and stored upright. So it should be always upright, the capsule, and be free from oil and dirt because it might catch fire. Qualification of welding procedures with filler additions. WPS is designed by the welding engineer to produce a joint with the required strength. It's a written document that guides the welder to produce a sound weld, and WPS contains essential and non-essential variables. Variable means a range where a particular parameter can be set within that range. As a general rule, the more liberal the range, the better the weldability, because poor weldability means more restriction, while good weldability means less restriction. Essential variables are those parameters that by changing them, the joint mechanical properties are affected, and therefore you cannot revise the WPS without requalification. This means you need a brand new PQR. Changing non-essential variables does not change the mechanical properties of the weld joint, and therefore requalification of WPS by performing a new PQR is not required. Simply revise the WPS with the same supporting PQR. So even if you are changing the non-essential variables, still you need to revise the WPS, but you don't need a new PQR or requalification. You can revise the WPS but not the PQR. You revise the WPS by changing its non-essential variables without the need for requalification. However, you're not allowed to revise the PQR because it's made of test report with the actual values of essential and, if recorded, non-essential parameters at the time of welding the coupon. Just minor typo correction is allowed. When Sharpie impact test is also required for qualification of WPS, then supplementary essential parameters, toughness, also apply. In this case, the heat input during the welding affects the mechanical properties of the joint, and often a preheat with restricted heat input during the welding or a post-weld heat treatment after the welding is required. WPS shall refer to supporting PQR and shall be signed by the organization or manufacturer taking responsibility for complying with the code project specification. A typical WPS gives such information as type and size of base metal, type and size of filler, consumables, electrodes, drawing of the joint profile, bevel angle, welding process, range of allowable amperage and voltage, welding speed, welding technique, any preheat or post-weld heat treatment, etc. Each WPS covers the range of wall thickness, diameter, amperage, voltage for a particular welding process. This is based on welding a test coupon and mechanically testing it, tensile test, and if heat input and toughness is a restriction or is a supplier essential variable, then a Sharpie test is also required. You can see a sample welding procedure specification here. It tells you the joint type, the material used, the filler metal used, the electrical characteristic, amperage, voltage, the process, welding process, the technique used, weave bead, stringer, multipass, and any post-weld is required, any preheat is required, and then welding procedure shows which process you use, which filler metal for each pass, and which amperage and travel speed, and etc. PQR is the supporting or the verifying qualification that includes the actual values of essential and non-essential variables used at the time of welding the coupon, as well as the required test reports, tension, Sharpie, performed on the weld that was produced as per preliminary WPS, PWPS. Essential parameters should be mentioned in PQR and non-essential parameters if recorded there. A record of what actually happened. PQR validates the weld design for or WPS. As a general rule, you should expect the following in a PQR. PQR number, logo of company, type of welding process, P number of the test coupon, the base metal, joint drawing, sequence of passes and actual electrode filler size and type, F number, AWS classification number, actual thickness and diameter of test coupon, actual weld deposited, actual voltage and amperage used, polarity, any preheat, interpass temperature, post-weld heat treatment applied, actual welding speed and technique, shielding gas type and flow rate, number and size of tensile test, and bend test coupons and the results, welder name, inspector's name, who supervised the test. It's a typical procedure qualification report, PQR, shows the joint detail, the material type, grade for filler metal, AWS group number, what was the thickness, the material here, schedule, for say pipe, for pipe thickness schedule and MPS, heat treatment, and what sort of mechanical test done here. Position of welding is not an essential parameter for WPS. This means a welding test coupon can be welded in any position. Preheat is sometimes used to reduce the thermal difference between the weldable and the adjacent base metal or heat affected zone, HSZ. Post-weld heat treatment, PWHT is mainly used to relax the stresses that were induced due to thermal difference between the weld and the base metal during welding. To avoid preparing and qualifying a WPS for every single type of metals and feeders, those metals or feeders that have the same composition, weldability, and mechanical characteristics are classified together as having the same P number or F number respectively. Tensile test of weld coupons for WPS qualification shall be equal or greater than the specified minimum tensile strength if the tensile strength achieved is at least 95% of base metal, and then it is acceptable provided the failure occurred outside the weld and the house region. This means that if you have a tensile value of at least 95% and the tensile sample breaks at the base metal, then the tensile test is acceptable. To determine ductility, you can have a root and face bend test. This is a root bend test, and if the face bend is the other way around, the face is going downwards. Sorry, this is a face bend test, and the root bend is the other way around. Nick break test is useful for determining the internal quality of the weld metal. For example, the greatest dimension of any gas bucket shall not exceed 1.6 millimeter, and the combined area of all gas buckets shall not exceed 2% of the exposed surface area. So that's acceptance criteria. There is a notch here, as you can see, and then a pendulum comes and hit it. So once it's break, you see the what is the situation there. So you can see here. It's forced, there is a notch here and notch cut, and then the hammer is applied, and then you do a macro. This is another one, the fillet weld. This is a butt weld. Qualification of welders. Typical WPQ or welder performance qualification contains welder name, date, and welding position performed, dimension of test coupon, thickness, diameter, parent metal, WPS number, welding process, filler type and size, any backing and shielding gas, result of visual and radiographic test or bend test. Radiographic test can be done in lieu of bend test. Or position of welding is an essential parameter for welder performance qualification. WPQ qualifying a welder is done by performing a coupon bend test or radiography of the weld to ensure that the sound weld is deposited by the welder. Welders shall carry a welder card that show the welding process, position, thickness, and diameter range qualified. Welders shall be recertified every 6 months, either by evidence of welding during this period or by requalification. Please note that the PQR demonstrates the strength of the weld design, whereas the welder performance qualification demonstrates welder's skill to produce a sound weld. That is why the mechanical test requirements for WPQ are either a bend test or radiography, while mechanical test requirement for the PQR is the tensile test. This is because the purpose and the essential variables are different for WPS and WPQ. For example, welding position is an essential variable for WPQ but non-essential for WPS. Design and preparation of a joint for production welding. Maximum alignment of pipe butt weld shall not be more than 1/8 inch or 3 millimeter. Misalignment. When the pipe is welded above ground, the working clearance around the pipe at the end at the weld should not be less than 16 inch, so the clearance under it should not be less than 60 inch for sufficient accessibility to weld around. That is also true during the field. This is a shop welding one. As you can see, the face of completed weld should be approximately 3 millimeter wider than the width of the original groove. So the width of the weld and the bevel width. Weld reinforcement shall not exceed 1.6 millimeter. That's a cap or reinforcement. Although we say reinforcement, but actually it is harmful to the weld, so as low as possible. That's good. And the maximum is 1.6 millimeter cap or crown or weld reinforcement. Inspection and testing of production welds. The company, client, or purchaser or owner has the right to inspect all welds by non-destructive methods or by removing welds and subjecting them to mechanical tests at his own expenses if they are in doubt. There shall be evidence of qualification of inspection personnel, certification, education, experience, training, exam results. NDT personnel shall be certified to level 1, 2, or 3 as per ASNT, SNTC 1A. All NDT personnel shall pass eye test, vision acuity in at least one eye, capable of reading Jaeger number 1, test chart from minimum 12 inch away. Eye test is valid for 1 year only. All NDT personnel pass color vision test initially and then every 5 years. Acceptance standards for NDT. This section shows weld defects and the acceptance criteria for RT, UT, MT, PT, and VT. You do not need to remember the acceptance criteria, just peruse through to get an idea. Cracks are always a defect and rejected. You should remember that NDE acceptance criteria for pipeline shall be as per API 1104 standard. All non-destructive test methods are limited in the information that can be derived from the indication they produce. This means if you find a discontinuity by MT or PT method that is say 5 mm long and the acceptance criteria is maximum 4 mm, therefore such indication is considered a defect and rejected, even though any subsequent examination by say a magnifying glass shows that discontinuity was in fact say 3 mm. Yeah. The reason is that because using a magnifying glass is an essential parameter, so you practically by change an essential parameter which affected the results here or the examination. So inadequate penetration due to high-low. Some weld defects you can see, incomplete filling here. You can see at this corner, at root on one side. Inadequate cross-section penetration. There is a back weld, but they are not fully overlapping each other. Incomplete fusion. It wasn't quite fused the weld to the base metal, as you can see here. There is no bond here. Incomplete fusion due to cold lap. So there was one pass, and then the other pass didn't fully sort of integrated with the pass, fused into the subsequent pass. So you have a cold lap here, or it can be here. And internal concavity. So you can see there is a change of color here. So because there was concavity, so there was less material here, so more rays passed. And then burn through. You can see the actual burn through here, and you can see here it's dots in the radiograph. These are burn through. Inadequate penetration with high-low. You can see right in the middle there is a straight line, so this is without incomplete penetration. As you can see here, this is less weld here, and then more rays pass. Repair and removal of weld defects. Company authorization is required for crack repairs, pack weld repairs, and double repairs. Crack welds shall be cut out, so anything is welded again. Twice repair needs company authorization. The client, any back weld repairs also needs client authorization, and any repair due to crack also needs company authorization. Crack welds shall be cut out. All repair welds shall have a length of minimum 2 inch, so minimum 2 inch weld repair. Welding repair procedure shall be qualified by visual and destructive testing. So if you are doing a WPS exclusively for weld repair procedure, again that should be by visual and the tensile test to see that with repair still it has the same strength as a normal WPS without any repair. When the production welding procedure was qualified with sharp impact test, sharp impact testing shall also be performed to qualify partial thickness and full thickness repair procedure. So if initial WPS has a sharp impact test, the repair should have also a sharp impact test. When wall thickness is over ½ inch, the side bend test shall be substituted for face bend or root bend test. Local location of excavation is also an essential variable for repair WPS. So when you do a repair procedure, you should cover all possible repair locations and extent of them in the joint. So it covers all sorts of weld repair because it's an essential variable, the location of excavation. Macro hardness, because HV10 test is required for qualifying repair WPS, and because of heated welding and removing and welding again, the hose region might increase considerably. So that's important that we check that the hardness is within acceptable limits, especially of the hose or heat affected zone. The repair weld coupon for WPS qualification shall be a minimum of 8 inch in length to provide the necessary weld deposit length for destructive test, excluding sharp impact test. So without sharp impact test, it is 8 inch at least. With sharp, it should be more, so that you get all the test coupons out of it, tensile test, sharpie test, etc. The welder shall be qualified using the applicable qualified repair procedure. So if you're using a welder to do the repairs, you should use, it should be qualified with the repair weld procedure. Procedure for non-destructive testing: when the radioactive ray passes through a medium, some are observed while the remaining passes through the material, reaching the radiographic film. If more rays reach the radiographic film, it becomes darker, and when less radioactive film reaches the film is lighter. The amount of radioactive rays observed in the material as they are passing through it depends on the density and thickness of the material. Since discontinuities such as slag, porosity, crack, lack of fusion, and the like have less density than the original material, therefore more radioactive rays pass through the defect. This means the radiograph is darker in those areas. A radiograph is practically a two-dimensional image or shadow of a material internally, and especially it is the discontinuity we are interested in. An NDT examiner interprets and evaluates the radiographs for difference in absorption and transmission results. In other words, the radiographic field interpreter identified the discontinuity by looking at the shadows within the radiograph, which shows the shape and density of it. So you can see here, we got a thicker material, this is lighter. We got a thinner material, more ray pass, it's darker. And here it is lighter again, because it's a thick material. And here you got a porosity or a slag. Actually it's a slag, looks like a slag. So there is not much density on a slag, so more rays passes, so it is darker. So by this shadow we can find what sort of. And then we got different hole type, step wedge type, or wire type indicators, image quality indicators called penetrometers. So practically what this means is that you put this wire or these holes next to the object to be radiographed. So if you can see the wire, like the fourth wire in this, normally there are 7 wires in wire type. So if you can see, let's say, the fourth wire here, and you know the thickness of this wire, it's a known thickness. So if you can see that, that means you can see any crack or any defect this size or this width or bigger. So that shows the sensitivity of the radiographs. Image quality is a measure of quality of an image in terms of smallest detail or discontinuity that can be observed. So this is a double wall, single image. So you actually ray pass through 2 walls, the top part of the pipe, bottom part of the pipe, thickness of wall thickness of the pipe, and then onto the fill. But the actual image we are interested in is a single view. We are just looking at this weld, not both the welds. It could be a double image, double wall, double image if it covers this weld as well. So this well will be shown somewhere here on the radiograph because of the angle is taken. Radiograph film shall have the required density, clarity, and contrast. Sensitivity of 2% or better for gamma ray and 1.8% for X-ray is required. IQI is placed on the film side always, except for pipe with OD less than 100 millimeter, when IQI is placed in the source side because that's not possible to see the IQI if it is on the film side. So IQI is always placed on the film side except with OD less than 100 millimeter. Geometric unsharpness means loss of metal definition. K is the result of geometric factors of radiographic equipment and setup. It occurs because the radiation does not originate from a single point but rather over an area. So D, the minimum distance in inches between the source or focal point and the source side of the object being radiographed. S is the size of the focal spot. T is the thickness of the weld, including reinforcements, plus the distance between film side of the weld and the film. K is the geometric unsharpness factor. So you can see here, you got some shadow here. This is geometric unsharpness. And this is where you get a clear picture because this area, the rays goes on different direction. So this is not very clear, the resolution. They call it UG or geometric unsharpness. Exposed film that show 10% of incident light pass through has a 1 film density, and then film density of 2, 3, 4 allows 1%, 0.1%, and 0.01% of incident light to pass through respectively. The film density should be 1.824, and geometric unsharpness should be 2%. You mentioned here. That is normally should be 2% or better. Film processing. Film needs to be processed in a dark room illuminated by red light. Films immersed in a developer bath. The film then is immersed in a stop bath, as you can see here, and then it get washed riser, and then it's hung to dry, and then this is a fixer, so developed, stop solution, fixed, and then hung, and then washed. So there are 5. So this is developer, stop bath, fixer, cleaned, the wet, and then hanging, and then washed or wetting agent. There is a radiographer viewer, and there is a strong light behind that, so you can see the radiograph. You might have seen something like this in hospital on the wall, and this is a close view of the radiograph. So there is a scale or a ruler to show what you're looking at, and then you can see the traceability, all these numbers for traceability of weld. This is the we just talked about. Ultrasonic UT inspection system consists of an ultrasonic transducer, pulsar, receiver, and display unit. Pulsar receiver is an electronic device that can operate high voltage electrical pulses to a transducer, which is a piezoelectric that when pulsed by a high voltage generates high frequency ultrasonic sound energy into the material in the form of sound waves greater than 20,000 cycles per second, and not be heard or detected by human being, and hence the term ultrasound. So you can see here there's a monitor, and there is a probe, there's a piezoelectric there, there's a voltage given to that, ultrasound generated, and it goes and hit the crack and come back, and you will see the crack here on the monitor. The receiver part of the monitor receives the reflected echo, amplifies it, and shows it on the monitor as a backwall echo. This is a straight beam technique using 0-degree probe, most suitable for measuring thickness and laminations. When there is a discontinuity such as crack, and the sound wave hits and reflect back, it travels shorter distance. Hence, you see pulse F, which is between the initial pulse but before the backwall echo, which reveals the longer distance, the whole thickness of the pipe. The distance between IP and F shows the depth of discontinuity. So you got the initial pulse, you got the back molecule, and you got the actual crack in between. Some discontinuities are at an angle, hence not accessible to a straight beam 0-degree probe. For each discontinuity to detect, an angle probe 60, 45, 60, and 70 degrees is used, and is called shear wave or angle beam technique, most suitable for detecting discontinuities in the weld metal. The sound wave travel time can be directly related to the distance that the signal has traveled. From the signal, information about reflection, reflector location, size, orientation, and other features can be determined. Coarse grain material casting observe or deflect most of the ultrasound and hence difficult to examine by UT method. You can see here the piezoelectric. This is the shoe of the probe, you have a shoe because the piezoelectric is very fragile and the sound goes through the shoe at an angle. So this is oriented at an angle, although it goes straight, but then it makes an angle. And this is a distance where you see the cracks, and the depth you can find where it is, at what distance from the probe, and then you can see also the depth. Sign of distance is sine of this into sound path, and leg or depth is cosine of this angle into sound path. And NDT level 1 or level 3 in the method shall develop the application technique as well as prepare and approve testing procedure. Level 2 or 3 certified personnel shall calibrate equipment and interpret test results, and NDT level 2-3 personnel in ultrasonic shall perform the test and evaluate the results as per the acceptance rejection criteria.